Hello everyone, welcome to another video. Today we're going to have a look at the quadratic equation. And the quadratic equation helps us solve quadratic equations. Um, so far, there's other ways that you can solve a quadratic equation, and that you could factorize, or you could try to factorize a quadratic, or you could sketch the graph of it and see, where it crosses the x-axis. There's a couple of different ways. This way is loved by students because all you have to do is plug numbers into a formula. And so what is the quadratic equation? Well, firstly, if you have an equation that looks like that, okay, so if you have ax squared plus bx plus c equals 0, so the quadratic must be equal to 0. That's the requirement here because it uses the null factor law in factorization. And so a is just the coefficient in front of x squared, b is the coefficient of x, and c is the constant that's sitting there. It must be equal to 0. If you've got that, then the answers, the solutions to the equation will be x is equal to, and you have it there. And that's something that you're expected to remember. You're not given that formula. That's something you need to remember. And where that comes from, where that comes from, is just purely from completing the square from this thing. So you can prove that yourself if you'd like to, and you're just looking at that equation there, and just completing the square. So factorizing out a out the front, and then completing the square with the b, b over 2, and then squaring it, yeah, b squared over 4, etc., etc. Anyway, I'll leave that for you to do, but you can come across that answer, no problems, by just completing the square of that. Not as easy as I just made it sound, but it is definitely possible for you to do. So there's the equation, and you're just putting it in. One thing that often trips students up is this little plus or minus here, okay? And we'll make sure that you understand where that comes when we do our example. So you get two solutions. Well, possibly get two solutions, where you get one solution if you use the plus, and you get another solution if you use the minus. And we'll have a look at that. Second thing that's worth noting is that we've got this square root here, and under the square root we have b squared minus 4ac, and that bit there is called the discriminant, okay? So the discriminant. And that tells us a couple of things. Now, if you think about it, if that discriminant is less than 0, then we're going to get the square root of a number that's less than 0. And you can't have, in the real world, you can't have square roots of negative numbers. And so if the discriminant is less than 0, then what happens is we're going to get no solutions, no real solutions. I'll put in here to make that clear. So you're going to get no real solutions if the discriminant's less than 0. Okay. And what that means is that this quadratic equation, the graph of it, if we're sort of drawing it, it actually does not cross the x-axis. So that's what we're trying to solve here. Because we're trying to solve where the quadratic is equal to 0, that means we're trying to figure out where does that quadratic cross the line. Where is that function equal to 0? In other words, where are the x-intercepts? Where are the zeros? Where are the roots? All the same. That's the same thing. So if you get the discriminant less than 0, it's got no real solutions. That means the quadratic is either looks like that or like that. It doesn't cross the x-axis, whether it's upside down or that way, it doesn't matter. It doesn't cross the x-axis, so that's what it would look like. How about if the discriminant is greater than 0? Well, if it's greater than 0, and I'll just choose a different color, then what we're going to get is we're going to get two real solutions. Okay, we're going to get one of the solutions from when we use the plus, and one of the solutions from when we use the minus in that quadratic equation. And so what does that look like? Well, it either does this, it comes down and crosses, and so you get two solutions, one solution there and one solution there. So these are the zeros. Or if it's upside down, you get something that looks like that. One solution there and one solution there. Okay, so these are the zeros. Hopefully that makes sense to you. Now, what about if the discriminant's exactly equal to 0? So if that discriminant's exactly equal to 0, what that means is that that's equal to 0. That means the whole square root's equal to 0. So that means none of that comes into being. Okay, so if that's equal to 0. So if the discriminant's equal to 0, then we get exactly one solution. So I'll put that in probably black, and I'll do it in blue. That we get one real solution. Okay, and if you think about, like, what does that actually mean? In fact, I'm just going to just delete this because I just realized I scribbled all over this. So there we go. So I've got to go, therefore, we get one real solution. So I just scribbled all over the formula so you can't even read it. There we go. So we get one real solution. And what does that mean? It means that it only crosses the x-axis once. In fact, what it does is it touches. Okay, so it either looks like this, touch, it goes up like that. So it only has one solution, either looks like that, or just running out of space, but I'll just jam it in here. Looks like that, or it touches like that. So that's all the sort of the different possibilities here. And so the discriminant can give you some good information about what the quadratic looks like when you sketch it out. And we'll talk about that in another coming video, but hopefully that makes sense. So let's just have a look at this. Let's have a look at an example to show you how to use it. So let's have a look at this. Solve 6x squared plus x equal to 2. Firstly, this is not in the form that we need it. Remember, to use the quadratic equation, it must be equal to 0. So we can just rearrange it slightly and go 6x squared plus x minus 2 equals 0. Now, once you have a look at this, there's a couple of ways. You could try to factorize this. And let's just quickly do it, right? Let's just have a quick look. So let's just try, so 3 and 2, so 3x and 2x. For that, I'm just doing some cross multiplication here. And 2 and 1, that gives me 4x and 3x, maybe. So that could be plus 4x minus 3x. Yep, so that's what it would be. So that actually factorizes to 3x plus 2x minus 1. Let me just double check that. 6x squared minus 3x plus, yep, that works, equals 0. And so if we used factorization, then the solutions that we're going to get for that one, we're going to get x is equal to negative 2/3. And for that one, we're going to get x equals half. So they're my two solutions here, okay? That's by factorization. But if you weren't able to do that, or you're not confident with factorizing, you can just use the quadratic equation. So we're going to do that now, okay? So let's look at it doing a different way. So a is the number in front of x squared, b is the number in front of x, and c is the constant. Make sure you're putting the negatives and positives in front of them like you should. Okay, so we've got that, and then therefore we just plug everything in. So x is equal to negative b, so negative 1 plus or minus the square root. Sorry about my squiggly square root there. B squared, so that's 1 squared minus 4 times a times c all over 2a, so 2 times 12. 2 times 12, so I did it in my head, sorry. 2 times 6. Okay, so just remembering the formula there. Negative b plus or minus the square root of b squared minus 4ac over, that's a 2 there, it looks almost like an equals or something, over that. And so now I just need to figure out what this is, and I just need to do some simplification, do some number work. So negative 1 plus or minus square root. Now what do we got here? We've got 1 take away, 4 times 6 is 24, 24 times 2 is 48. So that's actually 1, because it's a double negative, there will be 1 plus 48. Have I done that right? 24, that looks good to me. And over 2 times 6 is 12. And just to simplify before we do this plus or minus, 1 plus 48 is 49. The square root of 49 is 7, so it's going to be 7 over 12. Okay? Now, what does that plus or minus mean? This is the bit that sometimes students get to this bit and they go, well, what am I doing from here? Is one of the solutions is going to come from the plus, the other solution is going to come from the minus, okay? And so what we get is the following, okay? So that's equal to negative 1 plus 7 over 12, or negative 1 minus 7 over 12. Okay, so they're the two possible solutions. Remember, we said that the discriminant is greater than 0, we're going to get two real solutions. Our discriminant was 49. So we know we're going to get two solutions, and they're the two solutions there. And so negative 1 plus 7 is 6 over 12, or negative 1 minus 7 is negative 8 over 12. If we simplify that, 6 over 12 is half, or negative 8 over 12 is negative 2/3. Okay, and if you just remind us when we factorized it, we got that, negative 2/3 and a half, and so it gives us the same answers as it should, okay, because it's doing the same thing, which is solving an equation. And so that's how we can use the quadratic equation to solve a quadratic. The skill in the quadratic equation is knowing when to use it and when not to use it. And so if you got a question like this, and you go, well, can I factorize that? And how long do you play around with that trying to factorize it before you just use the quadratic equation? Because factorizing is quicker if you can figure it out quickly. But if you're sitting there trying to mess around with, all your factors and trying to figure it out, then you might get into trouble. And so maybe you try some factorizations. If you're getting into trouble, then why not just use the quadratic equation? It takes a little bit of working out, but when you get quick at it, it's not too bad at all. Okay, hopefully that makes sense. That is the quadratic equation.